Section 2.2, Frequency Distributions. A frequency distribution is a way of organizing your data into a table that allows you to get a better understanding of the nature of the distribution. It lists the data values, either individually or by groups of intervals, along with their corresponding frequencies. There are multiple steps that you need to take in order to create this, so let's begin. Step 1. Begin by collecting appropriate data. In this example, I decided to collect the shoe sizes of 44 different people. I then recorded my results in numerical order in order to easily identify the range of my results. Step 2. Decide an appropriate amount of classes you want within your frequency distribution. This should stay between 5 and 20. In my example, I decided to split up my results into 5 different classes. Step 3. Calculate the class width. The class width is the maximum value minus the minimum value divided by the number of classes. In my example, I subtracted 14, my maximum value, from 5, my minimum value, and divided it by the total number of classes, 5. I got an answer of 1.8, but since I could not have a decimal answer, I rounded up to 2. Don't forget, if you come up with a solid number, let's say 2, you must add 1, so your class width is really going to be 3. If you don't do this, your frequency distribution will have errors. The class width will help me determine my lower class limits, which are the smallest numbers that belong in the different classes. In my example, I start by taking the smallest number, 5, and put it in my first box. This is my first lower class limit. From there, I add my class width of 2, and continue listing my other lower class limits vertically as shown. Step 4. After recording the lower class limits, identify the upper class limits, which are the largest numbers that belong in each class. In my example, my upper class limits are 6, 8, 10, 12, and 14. With these, my intervals within my classes are now complete. Step 5. Once the class intervals are identified, proceed by entering a tally mark for each data value. When complete, add them to find the frequencies. In my example, I am going back to my original data set and entering in the appropriate marks. By using the tally mark system, finding the corresponding frequencies are made significantly easier. Step 6. Count up the tally marks and write the corresponding frequencies in the boxes to the right. In my example, I counted up my tally marks and found that my frequencies, going from top to bottom, are 9, 19, 9, 5, and 2. Now that I have both of my class intervals and my frequencies, I can say that this frequency distribution is now complete. Now that the frequency distribution is complete, there are a few concepts that you must learn. First are the class boundaries. These are the numbers used to separate classes, but without the gaps created by class limits. For my example, the class boundaries are 4.5, 6.5, 8.5, 10.5, 12.5, and 14.5. These numbers will be very important later when learning how to construct histograms. Don't forget to avoid the easy mistake of confusing a class boundary and the class width, for they are very different. The second are class midpoints. These are the values in the middle of the classes. The class midpoints are relatively easy to identify. For my example, they would be 5.5, which is the middle of 5 and 6, 7.5, 9.5, 11.5, and 13.5. These will be used later when using the frequency distributions to make different types of graphs. You can now officially call yourself a frequency distribution master. You now hold the power to create a plethora of graphs, histograms, and other types of distributions. Don't forget this on the final. I guarantee it will be there.